Happy to see everyone. Our session is about last sprint towards SA2 for P5 students. So what we're going to do today is preparing for P5 end of year assessment. So there'll be two speakers today. One is myself, Teacher Nick Tong, and another one is by my colleague, Teacher Hui Ling. So I hope everyone has a good session today, and we'll start shortly. All right. So I will start in a moment. So now let me introduce our two speakers. Maybe Hui Ling, talk about yourself first.
Hi everybody, I am Teacher Hui Lin. I am actually graduated from NUS and with a bachelor degrees of in chemistry with honors. So I've been teaching in this education for more than 7 years.
Okay, thank you, Teacher Hui Ling. This is me. I'm Teacher Ming Tong, or you can call me Teacher Mr. Lei. I graduated overseas and I'm also a teacher with a PhD in education. I was a former HOD science in the primary school and also the HOD ICT in the secondary school. So I'm happy to meet everyone online today. So let me introduce a little bit about BlueTree. Now, as the name blue indicates to all of us, blue is a nice, beautiful color. It's the color of the sky, the color of the water. It represents clarity. It represents wisdom. So this is something that we hope that when you see BlueTree, this is the first thing that comes to your mind. And then there's the word tree. What does tree represent? Tree has firm foundation. It has roots that branch out. It is as if we are sharing knowledge. So BlueTree, when this name comes to you, it resonates with clarity, wisdom, knowledge, foundation. And I hope with that, we are able to strike a chord with the parents and students. And let me go further, all right? So now we are talking about our philosophy. Our philosophy is as follows. We want to educate the world, students, parents, and teachers. Every child matters at BlueTree. We believe it is possible to create a future generation of critical thinkers who are passionate for learning and believe they can become high achievers in life. We believe that inculcating critical thinkers, cultivating passionate learners are the pillars for grooming achievers. It's not just about learning. It's not just about teaching. It's about the students becoming future leaders in more ways than one. And that is the main philosophy of BlueTree, and we believe this can be achieved with the help of the parents, the students, and of course the teachers here will play a part as well, right? So our teaching philosophy, this is the 3E framework. It is quite straightforward. The word explore, the word explain, the word extend. So we call it simply the 3E framework. And what it does is, like when it comes to BlueTree for science, the main thing is that we have a framework that will open the minds of all the students. We will give you a chance to explore. Now, look at the diagram you see on the screen. There are 3 spoons, a wood one, a plastic, and a piece of metal spoon. So with these 3, the students are given a chance to look at it and will tell themselves, if I'm going to do an experiment, putting a piece of butter on it, and the glass is full of hot water, there's a chance for something to happen. What is the thing that's going to happen? We'll see which butter melt first. All right, that is the explore part of the E3 framework. And if you look at the next thing, we need to explain, right? So what do we explain? We don't just believe in the pen and paper. We try to explain by talking about different types of questions and available to all types of questions. For instance, just now we saw the one that talks about the 3 spoons, about conductivity, about good conductors and poor conductors. All right, it's a very typical experiment type of questions, and we do the experiment in the classroom, and we'll explain it in the form of questions and expose your students to experiment types. Right, we even give the chance to the process skill and a few other things. Right, and look at the pictures you're seeing on the screen. Now, if we are only successful educators if we manage to extend our learning to real-life applications. Now, what is real-life applications? You look at the 3 things I'll show you there. There's frozen sausages, there's fish, and there's magnets. All right. Now, if you ask a student, how would you want to unfreeze or thaw the frozen sausages? They'll give you a lot of different answers. But are their answers right or wrong? Well, it depends. If someone will say, oh, I hit the sausage against the table or against the wall, I step on it, I jump on it, these are ways you can probably break the ice or freeze it. And there are no wrong answers. Of course, there are other simpler ways that you will tell them, put in a tub of hot water, etc. And you can look at the fish experiment that we exposed the gills to the students, and even to the P3 students, where we show the polarity of the magnets, which are strong, which are weak. And so we experiment with the different type of, show them that using iron paper clips, they're attached to the poles of the magnets. Right, these are things that we do, right? And we hope to extend whatever they learn in the classroom to real life. And those things you see on the screen are as real life as you can get, right? So we are actually ready to discuss how to prepare for your students who are P5 today. Of course, prior to this, we have had success with our students, and there have been several testimonials that talks about how successful the organization is, how our teachers have made a difference to your children. And are you ready? If you're ready, we're going to get Teacher Pulling to do some sharing that talks about, well, some questions that you'll be interested to find out. So if you're ready, take out your notebook and let's go to Teacher Reading now. Reading, please.
Thank you, Teacher Min Tong. Okay, so everybody, we will just start with the life sciences question first. And the first question is about the life cycle of animals. As you can see, we have a question here. The graph below shows the number of days of each stage in the life cycle of an insect. And we see the graph and followed by the question, how many days would the insect take to become an adult after the egg is hatched? Okay, so let's highlight a few keywords and also annotate. Make your thinking visible is very important. So we will use the graph and also take note of how many days the insect will be at each of the stages. And also next, we can see that the adults, okay, there are male and female, so they are all considered one adult stage. And therefore, how many stages does this life cycle of an insect have? Okay, I see your answers there. And this insect has 3 stages of life cycle. Yeah, so and some of you, as you can see, okay, that to become an adult, we don't actually count in the adult. And when we say after the egg is hatched, we will not count in the egg. Okay, so therefore, we are not supposed to count in the egg, and neither are we supposed to count in the adult stage. And therefore, it's supposed to be just counting the number of stages, I mean number of days in the name stage. Okay, so did you guess it right? I see a lot of number 3s and number 2s. Okay, so actually the answer, okay, can we reveal that the following is? Teacher Ming Tong, can you help? Yeah, so so therefore the answer is actually number 4. Okay, so which is we only count the number of stages. So the next question, so it's still the same graph, but now we are looking at a new question, which is how many days would an insect take to become an adult? But now the question has been changed a little bit. Okay, it has shown that after the egg is laid. So in this case, there's no need to count the adult, right, as per before, right? And now after the egg is laid, the egg is still there. And therefore, we need to account for the days spent as an egg stage. Okay, hence, therefore, we should be counting the number of days as the egg and the nymph. Okay, so in the graph, you see that it is 4 plus 12. Okay, so in total, we should be counting the answer, right? So the answer should be 16 days, and therefore answer is number 3. Okay, so let's go on to the next one. So let's recall as well the insects that have 4 stages. So remember, life cycle, there are many types. So not just 3-stage life cycle, but also 4-stage life cycle. And also recall that there are also other animals such as frogs and chickens, other than insects, right? They also have 3-stage life cycles. Okay, so let's go ahead with the next question. So question number 3 is an open-ended question. So this is a commonly tested question on human body system. So Alice ate a plate of spaghetti for lunch, and the graph below shows the change in the amount of undigested food that passes from his mouth to the small intestine. So we see the line graph here, and followed by the questions. A, complete the graph by drawing lines, and B, using the information at which organ does digestion ends. So state the reason. And C, describe how digestive system works together with circulatory system. Okay, let's go into more details. So as per usual, highlight and annotate those keywords in order to give you the idea and the clues on what kind of topic this is. Okay, so we can go on to question part A. So complete the graph below by drawing the lines to represent the amount of undigested food that is found in Alice's stomach and small intestine. So here we have to emphasize is drawing lines. Okay, so we have to read the requirements very carefully. It's not a bar graph, it's not anything else. It's just drawing lines. So this is talking about the stomach and the small intestine. So let's do a quick recap. So does the stomach, okay, small intestine, have digestion? Yes, they do. Okay, so likewise for the mouth, okay, so mouth, stomach, small intestine are the three organs that will digest. And so we have to draw a decreasing line since the amount of undigested food will decrease as digestion occurs. So particularly for the last one, which is the small intestine, it will have the fastest rate of digestion since the digestion is completed there, and therefore there should be the steepest slope. Okay, and take note that we should also recall that there is no digestion at the gullet and at the large intestine, and therefore there is no decrease in the amount of undigested food. Okay, so let's go ahead with part B. So part B, we use the information as given above and also with the graph and lines that we have drawn, at which organ does digestion ends. So we have to state our reason. So in this case, we should use the ABC answering technique for explanation questions. Remember, ABC answering technique is only for explanation questions. Not all types of open-ended questions are required to use this ABC answering technique. So let's go through one by one. A, answer with a choice. So we see that at which organ does digestion ends, we will have the small intestine, right? This is something that we know, but how do we derive this answer? We have to use the evidence which comes from the graph, and take note, there are two evidences in which we can use, and we only choose one to explain our choice. So the answer could be the amount of undigested food decreases the most at the small intestine. Or you can say the amount of undigested food remains the same after the small intestine, or what we are referring to is actually at the large intestine. So for C, confirm with concept. Okay, so confirm concept requires us to use the knowledge that we learn from our science lessons. So now, how can we support and link that back to our evidence that we have taken from the question or the graph? So we can say, to conclude, at the small intestine, the rate of digestion is the highest. If we are using the evidence, first evidence, the amount of undigested food decreases the most at the small intestine, or else we also can use so it shows that digestion ends at small intestine if we are looking at the second evidence. All right, so let's move on. So the next part of the question will be quite critical as it is quite a common exam question. So this question term describe how the digestive system works together with the circulatory system for the human body. So in this case, we have identified two systems. So digestive system and the circulatory system. So do take note, okay, to underline the key point. Don't worry, Charlene, okay, even though when we are going through this, okay, even if you are not done copying, don't worry, we will allow you to get the recording again to review it. Okay, thank you very much for your patience, and let's move on first. Okay, so for this part, we have two systems. So we have to use the answering technique of function, link, function. So let's use that. So what is the function of the first system, which is digestive system? And second, link digestive system to circulatory system, followed by the function of circulatory system. So the first one, function of digestive system, we know that you can actually have the digestive system to break down food into simpler substances. Okay, so how does these simpler substances actually get into circulatory system? So that's the linking part. So let's look at it. And the digested food is absorbed by the bloodstream. Okay, so that will be linking to the bloodstream, which is found in the circulatory system, followed by lastly, the function of the circulatory system is to transport the digested food around the body. So similarly, you will need this kind of technique for all other kinds of systems which require you to explain. So like for example, recall how does the respiratory system actually works together with the circulatory system. So you have to use function. So respiratory system allows gaseous exchange to take in oxygen, right? So followed next by the link. So the oxygen is absorbed into the bloodstream. So that's about the circulatory system. And lastly, the function of circulatory system is to transport the oxygen, okay, to all parts of the body. So that will be another way of answering this kind of question. So do take a look and review this kind of question because it's so common, okay, and it came out in the PSLE as well. Okay, so let's go on to the last question that we have for the life sciences. So question number 4, we have plant Y floats on the surface of a pond as shown below. So animal often visit plant Y. So the flower of plant Y grows above the water. So likewise, let's highlight, okay? So the key points over there, very important. It gives us a clue that it is about the reproductive system of in plants, okay? And we also take note to highlight the next point that it's the flower, okay, of the plant that actually grows above water. So having got the knowledge of all this context, okay, so part A, how does this characteristic help plant Y to reproduce, right? Okay, so now for this question, what do you think? Okay, so I can see that y'all will be able to get a few minutes to think about it. All right, thank you very much for your incoming responses. Yes, is it about making food? Is it about the water that the flower is in, right? Okay, so I have some of your answers and thank you very much for your responses. And so to let you have a clue on what actually is the answer, okay, you will have to take note and recap that the two methods of pollination of flowers is the animal and wind. Okay, so we have that the animals reaching the flower more easily and therefore being able to carry the pollen grains to another flower for pollination. Okay, so that will be the answer. So, and also take note that quite a lot of students will have misconception and get confused between the process of dispersal and also pollination. Okay, so be careful on that. So please do not write to help disperse the pollen grains or the seeds, because in the stage where there's flowers, the flowers have not grown or developed into seeds yet. Okay, so we have to use the process of pollination. Okay, so to answer some of your questions, okay, so this part here, yeah, we will be able to talk about reproduction, because to reproduce, we need the process of pollination as well as fertilization happening in the plant. Okay, so therefore is linked to this question on how it helps, because without the animals reaching the flower, and therefore there will be no pollination, then no fertilization, and therefore no reproduction. Okay, so we can move on to the next one. Okay, let's go to plant Y. Plant Y floats on the surface of the pond. As you can see, is the same question stem. So now let's read the next part of the question. Part B, complete the boxes below to state the other parts and process involved in the flowers of plant Y to become a fruit. So we have to take note of what is in the boxes, and the clue given to us is pollen grains. Okay, so let's do a recap. What is pollen grains? Okay, do y'all remember what's pollen grains? All right, so yeah, somebody will write stigma. Okay, that's a good try. So take note, okay, pollen grain is actually the male reproductive cell of the plant. So what would be the opposite, or rather the complementing cell that could fuse together with the male reproductive cell? Yeah, okay, so I have gotten the correct answer for some of you. Yes, very good. Okay, so we see that the ovule, okay, so let's look at that. Ovule is the female reproductive cell of the plant. Okay, so therefore we have to combine. Okay, so the combination is actually called fusing, right? So what's the process? Maybe you can put in as well. The process is okay, so some of you may put stigma in your answer. So take note, this part, it says in the clue, right? To become a fruit. So therefore, it's not pollination. So in order to successfully become a fruit, firstly, we must have the pollen grains to fuse with the ovule rather than the stigma, because that is not fusing. Okay, so therefore the process is fertilization. And let's recap. The fertilization is a process whereby the male reproductive cell in the pollen grain. So if they ask for how fertilization happens in plant, then we have to specify that it's in the pollen grains. Okay, then we say fuses with the female reproductive cell in the ovule. Okay, so take note to specify the specific parts when it's specified in the question. So how about the next part? So we can also recall that fertilization do occur in human as well. Okay, so you may want to just tweak the fertilization definition a bit when they ask for specifically how the fertilization takes place in human. Okay, why don't we use the word fuse? So in PSLE or any form of assessment, we would need keywords. So in science, keyword is a very important thing. And at BlueTree, we do emphasize and encourage our students to take note of the science keywords when they are answering open-ended questions. So fuse as compared to fertilization. So fertilization is the expected term, in order to explain it more clearly, because fusing could be just a joining of things. Yes, so we need to explain it very well. So we use the correct keyword to convey the intended meaning of the concept that we want. Okay, so thank you very much for your participation. Okay, so sure. Okay, thank you very much. Okay, so we can go ahead. So now the part C, fruit helps to protect the seed inside, right? Okay, is there any other function does the fruit have? Okay, so let's recall again. Is there any other function? Okay, if you ever learned it, right? This P5, in P3 you learn that fruits protect the seed. So how about in P5? Do we learn something additional about that? Yes. Okay, I do see your responses about helping. Okay, so some of you give me the answer pollination. Some talks about attracting animals to eat it. Yes, so what is the function? So why do they need animals to attract to eat it? Yes, so also the color of the fruit. So the color of the fruit attracts animal to eat it. Yes, and we see the key points is for dispersal of the fruits. Okay, so when we write, we must be very careful. Do we talk about pollination or do we talk about dispersal? So in this case, fruits, when we see the word fruits, okay, so we will use dispersal. Fruits and dispersal. Okay, it's either seeds or fruits will be dispersed. However, if it is for flowers, then we will have to pollinate it. Okay, so do take note on the most common misconceptions that students would have. So let's take note of the method of dispersal may also differ with the method of pollination. It could be that for the flower, it is dispersed by wind. But however, when it comes to fruit or the seeds, it could have the wing-like structure, hair-like structure to be dispersed by wind or could be even splitting. Okay, we are not very sure about that. So we will have to read the question very carefully. Okay, so please take note, is it about dispersal or is it about pollination? So do take note of the keywords flowers and fruits. So in total, there are 4 methods of seed dispersal. So we know animal wind and also water and splitting. So recall, what are the characteristics of the seeds or the fruits, okay, that could be dispersed by these 4 methods? Because these are really the commonly tested concepts, and we would also need you to be very detailed on what is the way of dispersing. Is it because it is being eaten? Or could it be because the seed is too large and it gets thrown away? These are also characteristics. So the other thing could be the things to recall is the dispersal pattern. So for example, those questions where you see dispersal patterns and they give you diagrams on where are the young plants around the parent plants. So then you get to see how the young plants or the seeds are being dispersed. So from there, we have to take note, how can we work backwards? Okay, is it because the plants are all lined up along the river? Or is it because it is being dispersed in a wind direction? Or could it be randomly scattered by the animals? Okay, and if not, could it be very close to the parent plant and therefore you know it's splitting? These are all the characteristics of dispersal patterns. So please be detailed in revising for reproduction in plants. It is a very important topic for examinations. Okay, so we can move on. So now we will hand over the time to Teacher Ming Tong to answer the physical science questions, okay, which will be very interesting. Teacher Ming Tong, please.
Okay, thank you, Teacher Hui. I'll take the physical science part of this set of discussion for the webinar. Now, I like to use PSLE questions. Increasingly, you'll notice that there are more and more schools taking the hint for how PSLE questions are set, and they will bring it down to P5 students and make sure that their exams are kind of similar as well. So, for instance, question taken from PSLE 2018, question number 18. So this question is asked in this manner. Atik placed 3 solids made of materials X, Y, and Z into a container of water. His observation is shown below. He made 2 statements. A, X and Y are the same material. B, Y and Z are different materials. Which statements can be concluded from his observation? And first option, A only. 2, B only. 3, A and B. 4, neither A and B. You look at the diagram, X and Y are 2 circular objects at the bottom of the container. Z was on top. So can I have a feel of the answers from the students? Parents, if you would like, you may join in as well. So I see Jen putting the answer as 2, Rachel 4, there's some 3 and there's some 2s, all right? So I'm quite happy to see a lot of response. So I shall share with you the answer in a moment. Right. This answer is actually B only, which is 2. Now, why is that so? I give an explanation as such, but before I say anything else, right, I just want to highlight to you the last statement that says this. This topic does not require the understanding of density, which is a secondary science topic. I know some parents out there will be thinking, hey, how come PSLE is asking this type of questions? Is it density related? The answer is no, it is not. What is important is that we must understand that this is a PSLE paper. We should not overthink the question. So the explanation is quite straightforward. Y and Z are different materials as Y sinks in water while Z floats on water. So statement B is correct. X and Y may be the same material since both materials sink in water. However, they may also be different materials that sink in water, such as a rock and a piece of metal. So with such a simplification of explanation for the answers, it actually helps to narrow down the answer to 2 quickly. So for P5 students, if you are preparing yourself for questions such as these, work on it the way you see. I mean, don't overthink the question. Don't apply secondary science topics or even sometimes the guidance are talking about density. No, it's a very straightforward answer, and you'll see that's the way it can be done, which is good enough. All right. So let's try a second question. Now look at this, question 28. This is about heat. Even though the word energy there, some of you are thinking, is it a P6 question? It's not. It's actually about heat, right? Containers in setup A, B, and C below are of the same size and thickness, but made of different materials. The containers are filled with the same volume of water at 100 degrees Celsius and left on the table. It's quite the question set is quite long. So sometimes when you look at it, oh my goodness, do I need to worry about this? All right. So key, highlight, annotate the key words that you see in the question. Maybe you look at the statement that says same size and thickness, different materials. All right. So bearing that in mind, sorry about that. The question is going to ask you, okay, I think the animation is kind of let me down, but anyway, the question is asking, which graph correctly shows the temperature of the water in a tree setup over a period of time? The options given there is 1, 2, 3, and 4. I kind of give the answer on the screen, right? But let's see. The answer is 4, right? I think you can see that. Now, why is the answer 4? Well, the answer is 4 because heat will be lost to the cooler surroundings, and metal is the best conductor of heat, and so the slope is the steepest. So I put a disclaimer below. do we need to know whether wood or glass is a better conductor? All right, let me rephrase and show you the question again. Maybe the diagram will refresh some of your mind. So glass is set up A, B is set up iron is set up B, and wood is set up C. So with that in mind, if you look at the options, right, I always tell my students, when you look at this, you should automatically eliminate option 1 and 2. Because regardless of the type of conductors, chances are they will lose heat over time and the temperature should drop. Right? Then you look at 3 and 4, and the answer is 4. Focusing your answer on B, which is a piece of metal. Metal is a wood conductor. So when you compare 3 and 4, the one that is a better conductor, in this case B, the slope would have been the steepest, as you can see here, dropping down all the way to here. Hence, the answer must be 4. Like I say, do I count A and C? On paper, I don't have to, because option 3 suggests that C has gone all the way down, which is obviously the wrong answer already. So with that in mind, you know that 4 has got to be the best answer here. All right, let's move on. So there's another question which I think I'd like to share. This is about temperature and heat. So the question is about state what is temperature. Okay, that's the very first statement. And then followed by this statement that says, Susan heated a beaker of water. She stopped heating when the water started to boil and recorded the temperature of the water every 5 minutes. Her results are shown below. Based on the graph, state the room temperature. Next, explain why it will be more accurate to record the temperature every minute for the first 5 minutes. Now, a P5 student looking at this will start to think, what is the question about? No, just now, teacher William talked about, we need to get ourselves used to some process skills and even experiment type of questions. Now, this is an experiment type of questions, right? Because this is what you actually do in the classroom, do in the science lab, and actually boil some water, heat some water, and let it cool down. So let's start with the first part. State what is temperature. So we'll look at B and C later. State what is temperature. Oh, sorry, there are a few highlighted points that you can see here. Over at BlueTree, we'll teach you a lot of things, including like state, 5 minutes here, room temperature, accurate. All these are things that you need to highlight carefully on your paper, or even if you're just glancing through, and you must know what to look out for. So for part A, state what is temperature. The answer is this. Temperature is a measure of the degree of hotness of an object. Take note that heat is a form of energy. Never say temperature is a form of energy, for instance. Right? Now, the second statement, based on the graph, state the room temperature. I need the students to recognize that this temperature is dropping steadily. I mean, sloping down quite fast, slow down, eventually reach a stable point, which is about 20 degrees Celsius. Students must be able to see that this part here is actually the 20 degrees Celsius is the room temperature. All right, you must see this part. And then the next part, which is very experiment, it says this. Why do I need to, let me show you the question again. I think some of you may be interested. Explain why is it more accurate to record the temperature every minute for the first 5 minutes. Previously, they're saying take every 5 minutes. Now they're saying every minute for the first 5 minutes, right? And the answer is, over the first 5 minutes, there is a greater drop in temperature from 100 to 50 compared to the rest of the 35 minutes. If the recording is done over 1 minute interval, it can better reflect the change in the temperature by the minute. Now, if you look at this question, right, some of the parents will be thinking, this is something that we need to be very careful as to how to answer, right? So if you are able to see this part, that 1 minute interval allows the person doing an experiment to track the detailed drop, it will be a plus point. This is how you actually do this, right? So parents and students, take note of experiment type of questions. It can be as detailed as such, right? I'm going to move on fast now. Next one. All right. This question is a fairly common question. You should have seen this before. A worker used a truck to deliver blocks of ice. A mist was seen when ice was taken out of the truck. Part A, explain how the mist is formed. Part B, the mist disappeared after a short time. Explain why. And then the third one, Part C, which is a very unique question, I thought, when I first saw it some years back. Thick plastic strips were hung at the door to prevent the ice inside the truck from melting. Explain why. Now, if you don't observe this outside, this is something that you don't see them, do you? So when this question comes out, first of all, there's a few things you must take note. A mist. What is a mist? Is mist water vapor? Is mist water droplets? Now, if you are a primary school student by now, you must know mist is water droplets. All right. So how is it water droplets? Because the word seen was given there. Obviously, you can only see water droplets. You cannot see water vapor. So you're supposed to explain how the mist was formed. But before that, there's a part 2 and there's a part 3. They say thick plastic strips. You saw us arrow pointing to this particular item there. Look at the diagram. There's the mist and there's the thick plastic strips. Right? Remember, what are these strips made of? They're made of plastic. Right? So let's look at the answer of the first one. The first one, how the mist was formed. Now, this is something that our school will teach you very frequently about some kind of acronyms like warm water vapor comes into contact with the cooler surface, loses heat, and condenses to become water droplets. So you can see the word WCLCW. These are ways of us teaching the students to land on a catchy acronym or phrases, and they will forever remember how water droplets, or in this case, the mist, was formed. And then part B, the mist disappeared. How do you disappear water droplets? You must always think, the only way for water droplets to disappear is it must become the gaseous form. So how does it happen? It gains heat, it evaporates, it becomes water vapor. And that is why it disappeared. And the last one, no, the plastic was there. Why are the plastic there? The plastic are poor conductors of heat. They conduct heat slower from the warmer outside surroundings to the cooler inside of the truck. Thus, the heat gains slowly by the ice and it melts very slowly. So when you apply the knowledge that you have and apply to real life events, like we're talking about the 3E framework, here is an example of applying the 3E framework. All right, how the plastic reduces the rate of ice melting. Okay, so another question, I'm going to go a little bit faster, sorry about that. Peter built a door lock as shown. When he closed the switch, the iron bolt moved to the right away from the catch and the door was unlocked. Now, students, the diagram and the question are your best friend. But this is what always look at the tree, right? And you look at this diagram, it has got to be something to your advantage, is your evidence. You look at it and understand the diagram first. There's an iron bolt. What is an iron bolt? Look quickly. There's a catch. And there's a electromagnet setup there with a switch and 2 batteries. There's a spring there. So the setup's there for you. Take a look. What do you think they'll be asking now? Let's see. First question. State why copper, a type of metal, is used to make wires. Which wire are we talking about? We're talking about the wires. Here, the wires is coiled around the fixed metal cylinder, all right? And explain how the door was locked when Peter closed the switch. The next one, when Peter opened the switch again, he found that the bolt did not go deep enough into the catch to lock the door properly. And then they said, without changing the iron bolt, suggest changes to his setup so they can lock and unlock the door properly, and explain your answer. Now, look at the mark distribution. It's 1, 2, and 2. It's a 5 marks question. All right, I'll pause for a moment, let everyone glance and take a good look about this. All right, I'll slow down a little bit for some of you because I think I'm quite aware of the time as well. All right. So let's see. So far, all right, very well on this part. I'll show you the diagram again just in case, all right? So this is the diagram talking about how to make the wires, why is it copper, etc. So now, the first part of the answer is as such. Copper is a metal, and you'll see the answer shortly. Copper is a conductor of electricity that allows current to pass through. Now, this is a very important part. Then we say it is a conductor. Now, you cannot just write down copper is a conductor. Why? Because it could have been misinterpreted by the marker that copper is a conductor of heat. So you must be very careful and put down the word copper is a conductor of electricity and allows the current to pass through. Right? The second part. Explain how the door was unlocked when Peter closed the switch. Students at P5, you should be very clear about this thing right now. When the switch is closed, current passes through the coils and the metal cylinder becomes an electromagnet. Some of you call it a temporary magnet. The electromagnet attracts the iron bolt towards the right and unlocks the switch, unlocks the circuit, all right? The door, rather. And then the third part, which is a more interesting question, is actually open-ended literally, meaning that without changing the iron bolt, what can I do to make sure that the iron bolt can go into the catch? So we list you 1, 2, 3, 4, 5, right? For students who are looking at this question, I know it can be a little bit daunting, but if this question comes to you at the P5 level, you must be ready to answer. And there could be a variety of answers. For instance, we will recommend a longer spring so that there is a sufficient distance to go into the catch, move the metal cylinder or the circuit closer to the iron bolt, increase the number of coils, increase the number of batteries so that the cylinder becomes a stronger electromagnet. And the last one, which I want to see the thought in some of you, is what about adding lubricants, right? This is something you learn in P6, but for the sake of discussion, I just want to bring this up for now, talking about lubricants, right? So this is a fairly high order question for PSLE students. I'm not too sure the P5 will be testing on this, but I suspect they will give you part or elements of it, right? So we have shared with you quite a few questions. I hope parents can see the nature of PSLE questions. I will say this, increasingly there are more and more application type of questions. And students have to think about thinking out of the box sometimes and also try to get a feel of what is happening, right? You must be ready to let your child explore. Hence, get them to read, see documentaries, or even get them to hands-on of some of these things to play with, to have a chance of how to do science questions. So these are challenges in open-ended questions. I will not deny that. You know, there's a need to strengthen the concept, right? This is a fact. In fact, for all topics that you go through in primary school or secondary school, these are topics that you must go through where the concept must be strong. Students must know about the experiment. They must know to enhance the process skills. This is some of the things that they must be prepared. I'm not surprised if I see students struggling open-ended questions, to be honest with you. Even for teachers, when we look at some PSLE question for the first time, sometimes we also struggle to see would our answer fit what the PSLE expect as well. And the second challenge I feel sometimes is the keywords. While I am reluctant to say that you have to memorize every keyword, it is important to understand these keywords must be used effectively, used in a way that resonates with the question, applies with the question. Right? These are things that they need. And sometimes you'll be surprised. Some students will spell the words wrongly. So please make sure that the students can spell some of the keywords like condensation or fertilization, you name it, stigma, all of this. They must know how to spell the keywords. Right? It is always important to understand the question. All right, that's why we analyze and annotate. This is part of the BlueTree strategy we will teach you. Analyze, annotate some of the keywords, answer to those keywords in the question. And of course, there's a lot of effective strategies and application. And the answering technique that teacher will talk about, the ABC, for instance, the function link function, for instance. So these are things that you heard. And I want to share with you a sample of our students' work. For instance, what is wrong with this piece of work that students have done? Now, you look at it. What are the mistakes? The mistakes is there for you to see. I will not elaborate on it. If you look at it, the answers is quite a fair bit. But the student have written some things. But you saw him striking off certain part of his answers, right? Now, actually, this is something that parents, you be careful when you see some of this thing. Because it represents some incompleteness of the answer, that's one thing, right? But it also tells you that the student is lacking perhaps confidence and also telling them that they may not have the right technique when they're answering this question. So in this case, the question is asking you to to see for A, B, and C, for which one will cast the darkest shadow on the screen. So there are three options. So the student must be able to read the evidence from the graph, read the evidence from the question, and answer. So with such an A-B question, the student must know how to answer. So we always advise these three things. For instance, the first one, let them get used to such questions. Let them get used to the answering technique for such questions. All right. What kind of question is this? You'll see there's A, B, and C. So it's going to be some form of comparison. So you'll see here, check if all the keywords are applied. Check if this is a comparison question about A, B, and C. Yeah, it is a comparison question. Isn't it kind of? So A has a particular amount of light passing through, B has a certain amount of light passing through, and C has a certain amount of light passing through. So when you see such questions, you must be able, for the students, you must be able to answer with confidence and with conviction, and you must be familiar. You cannot be seeing this for the first time. There's a diagram, there's a graph, and there is a way the question is asked, and you must be ready to answer it. All right? Another type of question. This is a similar question to the one that you see just now. Now, you'll see the answer there. The student answered fairly accurately. Look at it. The warm water vapor touches the cooler surface, lost heat, etc., etc. But, well, you will see that there are gaps as well, isn't it? The teacher put some red carrots there and some red markings. The answer is not complete. And he did not answer the question in full. It's too short. So when this happens, same thing again. There are ways that we're teaching you. You must get an acronym, some of the keywords there, and you must be able to read the question one more time. Imagine you are wearing the hat of the teacher. How would you expect your students to write it? So you have to be confident of your answer. And the completeness of the answer is what gets you across the hump. All right? So parents, hope we can understand, science questions is not as simple as we see. We need you to see the choice of the answer, the evidence, the concept very often, and that is why we emphasize on this thing. Right? Now, there are many strategies that we would like our students to do well. I identify them, as you can see here. Like when you see a question, identify the key concepts, highlight the key information, identify and highlight the key question term. Look for the word state, describe how. Okay, parents, feel free to take a picture of this. Use a key answering technique, ABC technique, or whatever your school advise you. All right, I've heard a variety of techniques that the students have shared in class. And whichever technique they have, teacher have told them, or even if you come to the center and we introduce the ABC technique, which is similar to claim evidence reasoning actually, but we will guide them along the way. So for parents, if you are with us, look at all these different strategies, and I'll give an example how we actually do this. All right. Hold on a second. All right, let some parents take a picture of this. Now, give an example of this question. Now, Ethan went for a morning exercise. He ran to the entrance of a park, he took a brisk walk, and he does a few things. And after that, which one of the following graphs show the changes in Ethan's heart rate from the time he left his house? So I kind of highlight a few things in the question, and students who have time, I give you 3 seconds to think of the answer. Right? Actually, the key is given on the screen itself already. Right? So I'm going to pause and let the student think what answer makes sense for you. Okay, JT is very fast. He said the answer is 1. Right? I'm going to follow up with another question and say, those who said 1, right? Why is 2 wrong? Why is option 2 wrong, for instance? Right? I'll just narrow down to this. Very simple. So students, when you look at this question, the answer is 1. It is 1. Why? Look at the part where I annotate on the question. Ran, brisk walk, resting, run. All these things are annotated in the option 1 as well. And it kind of match aligned. Hence, answer is 1. And why is answer 2 wrong? Look at this part where I highlighted the part in yellow and I circle it down. Apparently, heart rate reaches 0, which means this person did not even breathe. He died while running. So obviously, this answer is going to be wrong, isn't it? So student, you must be able to see Yeah, I see this one by Evan Tan that says, because when you rest, you will see a heart rate while 2 has no heart rate while resting. Well done. EB will all say the same thing. Right? Good job, students. So, see, our students are able to identify such things. But they're able to understand why the heart rate 0 is a wrong thing. Right? So, another question I'm showing you. Oh, this is a very lengthy question. Oh, it's about wind turbine, blah, 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 blah. Now, when the student look at it, identify the key topics and concept here. All right, I won't go through detail for this one in the interest of time. But what you see here is an example of how you should address a long, fairly verbose question, identify the topic, electrical systems, highlight the key information, all those things highlighted in yellow, this is what you're looking out for. Look at the graph. There's 2 graphs there, rotation speed of the windmill, electrical energy generated. Students must draw the link to the 2 graphs, all right? And then look at the key question, how should the length of the wind turbine be changed, etc. And use the key answering techniques for such a question. All right, you can see the way we phrase it in the whole question, the way we teach our students. And this is how the student should approach when coming to the P5 SA2, right? So here is the way, same thing again. When we teach the students, look out for the diagrams, the graphs. These are your best friends, right? If you analyze those information carefully, your answer that comes out towards the end, let's say part C, for instance, right? Z as a speed is the highest through the months as the most kinetic energy is converted to the most electrical energy. Now, these answers are there, but it's only possible if the students pay attention to the question and pick up all the key evidence and then put that into your complete answer. All right, students, I know I'm talking a bit fast, but if I don't, I think I'll wear you out as well. So parents are going to move on to the last parts about what the school is going to do, some of the things that BlueTree is coming forth. I'll get my colleague, Teacher Willing, to move on from here. Teacher Willing.
Okay, so like to inform you regarding on the upcoming webinars that we have for all P5 students. So do join us for the science on how to tackle science open-ended question with confidence. Okay, so we will be having this webinar. So it's a 1-hour session on 3rd October. Whereas for math, it will be on 5th October, okay? Also a Thursday for this 1-hour session. So if you would like to join us, so we have the link. Okay, so we will be getting the link in the chat and you may want to register from there. So these 2 sessions are free, so do come and join us again. And we have the upcoming masterclass, which is a paid section. Okay, so if you are interested in the math and the science, okay, we have 10 October and 13 October respectively. So you can just sign up with us using the link as shown as well. So the last upcoming talks that we have is for navigating the journey from P6 to Sec1 transition. So for parents who have P6 students, so you are welcome to join in and listen. So we will be having a sharing here, right online via Zoom on Friday, 24th November. And if not, you may want to join us physically at the BlueTree headquarters, right at Orchard Branch, Singapore Shopping Centre. So it will be on the 26th November. So the links are as provided.
So thank you, Teacher Hui, for sharing these upcoming talks and webinars by the planner. We hope to see more of the students and the parents coming on board to really make a difference to the students. All right. So with that in mind, we would like to thank you to attend and sharing. If you like the way we share the information, it will be useful that you can drop us a comment about on our Facebook or Instagram. And Really appreciate everyone for showing up, especially the active participation by the students. When you ask you for your response, I thought that was great, and I think that's the way we should be doing this. Parents, do not worry, you're not in this journey alone. Our center is there to help you, and I hope that you walk the journey with your children together. So it's 8:30. I'm confident that some of the students should have benefited from our session. I'm also very confident that we have done our best sharing. And I would like to thank Teacher Hui Ling for today's sharing. So, Teacher Hui Ling, is there anything else that you want to comment about?
Yeah. Yeah, just want to thank everybody for coming and joining us. Hope this session has been beneficial for everyone. Thank you and have a great evening.
Right. With that, I will close the session. So thank you everyone for showing up. Once again, bye-bye.
Thank you both. I was in the background. Did you realize?